Hello and welcome to my short introduction to the nested polytope problem is ETR complete. This is joint work with Michael Devons and Andreas Holmsen, and my name is Tilman Mills, or just Till. Okay, so let me tell you about the nested polytope problem. We start with dimension 2. We've given in the nested polytope problem an outer polytope, an inner polytope, a number, and we try to find a polytope here in 2 dimensions polygon, which is in between, it's nested between the outer and the inner, and it contains the given number of vertices, in this case 5. And we have 1, 2, 3, 4, 5. That's a nested polytope problem in 2 dimensions. We can have the nested polytope problem also in higher dimensions. Let's have a look at an example for dimension 3. Here the outer polytope would just be the cube. The inner polytope would be the convex hull of these blue points. So the inner polytope is given by its vertices, and we've given as number 5. So we need to contain those 3 points here, because otherwise they cannot be contained in the nested polytope. So, for instance, so we need to choose 3 on this left plane. We need to choose 3 on the behind plane, and consequently we need to choose 2 on the bottom plane, and that means we need to choose them in the way that I've indicated here. And now, if we look at the bottom plane, one vertex. If the one vertex is given, the other vertex is determined. But there is some choice on how so this vertex would be this vertex can be chosen, and there's a continuum of choices. Okay, so this was just to give you an example how the nested polytope problem looks like and how potential solution can be done. So why should you study the nested polytope problem? Well, there are 3 reasons. The first one is just a fundamental problem in both computational geometry and polytope theory. You could think of it for an application. If you would want to look for an application, you could think of it, this is a polytope simplification problem. Given a polytope, I can expand it, and I try to find a smaller polytope in between the original one and the expansion, and then that should be a simplification of the original polytope. And I think the strongest motivation to study the nested polytope problem is because there are very close relations to matrix factorization, and due to this close relations to matrix factorization, all vectorization also to stochastic and machine learning, but I don't explain those relations here. Okay, so what is the result that we got? We showed that the nested polytope problem is ETR complete. We also figured out that this was already known, not explicitly pointed out, but if you read the paper of Shitov and a paper of Cohn and Rockblum, then you can get that result very easily. Here we give a simple in our paper we give a simple geometric proof. Let me point at 2 things here. So to show ETR membership, you can describe all the vertices using real numbers, and you have to encode 2 types of constraints. You have to show that you contain in the outer polytope and that you contain the inner polytope. And both of those things can be done with algebraic constraints. I will not show you how, but it's a little bit tedious, but it can be done. And just to give an indication, maybe as a first step, how you can show ETR hardness. So how could you encode a variable? Well, maybe if you have this outer and inner as indicated here, then maybe if you force the 3rd vertex to be on this bottom line here, then that could represent a variable between 1/2 and 2. Okay, but of course you need to be a little bit careful, because it could also be in the interior, the bottom vertex, well, you have to take care of this. And of course you have to do many other things, which I will not explain here. Okay, thank you for your attention, and look at the longer video or look at the paper if you want to know more. Thanks.